So you have given an alkyne and you have to obtain this. Okay. The first thing that you need to understand here there are 3 carbons and here there are 6 carbons, which gives me the idea, okay, this is just the number of carbon is double. So there should be a way that should double from here to here. So if you typically remember, I have told you many times, in general, we use the Grignard reaction to increase the number of carbons, because Grignard reaction is the mostly used reaction in the world, right? In all organic chemistry, Grignard reaction is the mostly used one. So here you have 3 carbons and I want to just double the carbon number. You can go through a Grignard reaction. So that is why they have given this magnesium ether, PCl5 and all those things. Okay. So we will go through this list of chemicals. So HgSO4, H2SO4, which means you can remember this is the hydration through a triple bond. So this can be our first step, right? Then we have NaBH4, which means you can reduce a compound. So we will see whether we need to use it or not. Then we have PCl5 and magnesium ether to form the Grignard as well. Okay. So I will use the board again, which will be easy for me. Okay, so this is our reactant, CH3CCH. And our product is this one, right? So always I told you, try to come from here and try to connect these two. Okay. So what can I imagine the step that might be before this? What compound can be? Since in the list they have given concentrated H2SO4, I might think that the step before this is a dehydration step where you have OH in one of the carbons and hydrogen in the other one. Since I have given conc H2SO4, so I would think this as conc H2SO4. And when you remove this OH and hydrogen, it will form this. That is one idea. Okay. Now I have to come from here to here. Okay. Since this is a triple bond, and you have already given the list of the chemicals HgSO4 and DIL-H2SO4, I would add this one here, HgSO4, DIL-H2SO4, which gives me the compound CH3CO CH3. Okay, this is this, and this now will give me the idea, okay, if you have this type of a ketone and if you react this with a Grignard, I would obtain a compound like this, because here this part I see here, see, this one could be a CH3CO CH3 and attacked by a Grignard which is from here. So this reaction can be CH3CO attacked by a Grignard compound CH3 hydrogen is here, MgCl, and this MgCl can attack here, and we should add H plus H2SO4, which means they have given diluted H2SO4, DIL-H2SO4. First we have to add this, second we have to add diluted H2SO4. And here this Grignard will attack here to form this entire compound. Now where is this compound? Two people entered the waiting room. Admit, admit. Right? So we have this compound as well as this compound which should be formed. So this Grignard can attack this compound and form this one. So where is this? We have already formed this from the beginning. So I want to form this compound here, the Grignard, from here. Right? So I will explain it again. So I thought this compound would come from here, from the dehydration. Why it is dehydration? Because I have given conc H2SO4 in the list. So I thought this is a dehydration. Right? Then from here also, since this has given a triple bond and it has given this HgSO4 and H2SO4, I thought this could be this reaction where it's the hydration. So when you do the hydration using HgSO4, it will form this compound. And this structure I see here, which is CH3COCH3. And if I think this as CH3COCH3, I can imagine this should be the Grignard that is attached to this CH3COCH3 like this. So here, this structure I have already here. So I don't have to make that anymore. But I have to make this compound from here. So I am going to check the list. They have given what? They have given NaBH4, which gives me that CH3COH, CH3, the reduction. And then you have given PCl5 to convert this as a Cl compound. And then finally, you can add magnesium dry ether to form this Grignard. And this Grignard will attack this one to form this, and dehydration will give this. Okay, so try to understand that. Right? So we came first to this place, and we came first to this place, and we try to combine. That is how you combine. You try. Okay, this part, can I see here this part? Okay, I have seen 3 carbons. Okay, here and here as well. But I see here this alcohol can be formed from a ketone. That is why I see this part here. So how this alcohol can be formed from this ketone? More or less, this part should be a Grignard because they have given this Grignard reagent forming reagents. So you need to understand that. Okay, so this is one of the ideas that you can use to predict the structure of this intermediate compounds and the reaction scheme. Okay, so this is done. So if I share the screen, so I have used all these chemicals that you need to use here. They have given. Okay, so we will go through the second one. So you have given another compound that is A. So I will first draw A. This is A. Sorry. This is NH and this is our compound that is they have given. And we have to make this one. CO Cl. Right? So again, yeah, I will stop sharing so that you can see the board. Right, so this is our structure, initial compound, and this is our final compound. So again, we will think from where this should come, right? So it gives me the idea, this compound, the structure that I have considered here might come from a Friedel-Crafts alkylation reaction. Can you think about what I am saying? What I am telling here is this should come from COCl anhydrous AlCl3. COCl from this part added to a chlorobenzene. When you have chlorobenzene, or either let's say just a benzene, if you can remember now this one, this is benzene, and if you can remember the reaction with CH3Cl anhydrous AlCl3, it forms a CH3 compound. And in the same way, this is Friedel-Crafts alkylation, and in the acylation, CH3COCl anhydrous AlCl3, this should be anhydrous. This CH3CO group is attached here, if you can remember, COCH3, right? This is alkylation and acylation. Now here I am talking about this one, the acylation, where if you have COCl and if you add this to a chlorobenzene, this COCl will be attached according to this structure here as CO, this entire benzenic structure. Why here? Because chlorine is a ortho-para director and will be added to in the para position. That is the idea. Okay. I will erase this one here. And yeah, this will be our idea. Okay. And now, how do you come from here to here? That is my next question. You need to come from here to here. So you need this compound along with this. You need to come from here to here. The easiest way to do that is, since this is an NH group, first thing that you can do here is attach a chlorine here. So if you do Cl2Fe or Cl2FeCl3, first thing that will form here is there will be a CO, there will be a NH, there will be a chlorine that is formed. Then you can hydrolyze this to form COOH, NH2Cl. So I see this compound here, right? What you have to do? You have to add just PCl5, because if you add PCl5, this COOH will be converted to COCl. But how do you get this compound from here? First, you have to convert this to an N2Cl group, and then you need to add H3PO2 to remove this N2Cl from the benzene group. So this is the typical way that you can do, right? So how do you get NH2 to N2Cl? NaNO2HCl, 0 to 5 degrees Celsius. So this is the normal way that you need to obtain, right? So we will come again from the beginning, right? So the idea here is you have given this structure. Okay, so you have given this structure and I have to take it from here. Okay, so here according to this structure, the only possible way that comes to my mind is it should be a chlorobenzene attached to a acyl chloride compound. So how do you obtain this and this? It is from here. You can first attach a chlorine and you can hydrolyze it to form this one. Or you can first do the hydrolysis, then there will be no chlorine, only this one will form, and you can use PCl5 to convert it to this one, COCl, which is this compound. And when you first hydrolysis, do the hydrolysis, it will form NH2 benzene. Then you can convert that into N2Cl, and then you can add chlorine and you can add finally H3PO2. Okay, so there are two ways to do this. One is first you can initially add chlorine, which I did earlier. This is the preferred method, which is the easiest one. Or otherwise, what you have to do here is first do the hydrolysis and then add chlorine. Okay, so you can do this in two methods. Either first add the chlorine and do the hydrolysis, or either do the hydrolysis and then add chlorine. It is your wish. Okay, it is your wish. You can do as you want. That's the idea. But always try to understand the method that I am going. I am trying to come from here as well as here. That's the idea. It is better in a conversion that you come from the back at least few steps, 2 to 3 steps, than coming from the front. Because always your first molecule and the last molecule will be different. So if you come from the back thinking your reaction, what reaction you have, you can come up to a certain point where you can try to connect this with this. That's the overall idea of all chemical conversions, right? Organic conversions are like that. Right, so this is our idea. So you might have a question why I have used directly these inorganic chemicals. The main point is you can use only A as the organic material. So you cannot use other organic materials. Now here in this particular reaction, all that I have used reagents are inorganic. See, Cl2Fe is inorganic, PCl5 is inorganic, NaNO2HCl is inorganic, H3PO2 is inorganic, and hydrous AlCl3 is inorganic. So all reagents that I have used here are inorganic compounds, right? So these two questions will be done. And the last one, it is possible to synthesize the following compound X using two different pathways. Each pathway can be written as a nucleophilic substitution reaction. So think about the structure that they have given, right? So this is a ether. What is this? This is a ether. So remember, in your syllabus, we don't have reactions belonging to ether. We have only the synthesis of ether. There are mainly two reactions like this one that they have asked here. These are the only two reactions that typically comes in your syllabus and you need to know, right? So what I will do here, so I will use the board again. Right, so the idea is they have given the structure. CH3, CHOH, no, COCH3, CH3, right? So this is a ether, right? So I will tell you how we form ethers, right? Typically how you would form ether. So when you have a compound like this to form an ether, we use two different methods. One is, if I go back, this should be like this. This should be like a ONA compound, and this is our nucleophile that can be attacked to a CH3Cl. So this nucleophile can attack here, and this will form the nucleophilic substitution, and this will remove. This is one of the way. And how do you obtain this one? You can obtain this one if you have this alcohol, OH, and you reacting with sodium, because alcohol does not react with sodium hydroxide. So we react this with sodium. So if you have an alcohol, you first react it with sodium to form the OA, so O minus. Okay, then you add it to an alkyl halide. So this is our first method. Okay, so this is our first method to form this particular compound. So what is the other method? So the other method is the reverse of it. What is the reverse? So you will have this alcohol like CH3OH. Okay, then you first add sodium. So it will form CH3O minus Na plus. Now here this will be your nucleophile. Here it was this, the nucleophile. And now this nucleophile can add similar type of compound where alkyl halide. Okay, this chlorine will be removed. So again, this is your second method. So again, you can see I used here alcohol, sodium, alkyl halide. Alcohol, sodium, alkyl halide. So these are the two methods that you can use in order to prepare ether. Okay, what is the only criteria? You need to use the alcohol, sodium, and alkyl halide, because the nucleophile can be changed in both ways. What is the both way? Here the nucleophile is this because of the negative charge, and here the nucleophile is CH3ONA because of the negative charge. Here this one will attack CH3Cl alkyl halide, and here this will attack the secondary alkyl halide. That is the idea. And finally, from these two, like these two reactions, the same compound ether is formed. Okay, so these two are the things that they are asking in the question, right? So write the reactants for each pathway. You can write down the reactants. So here one of the reactants should be this one, and the other reactant should be this one. You cannot write alcohol, because if you write alcohol and alkyl halide, you cannot have a direct reaction. You need to first add sodium, then you need to add. So your reactant should be this one and this one, this one and this one. One should be an alkyl halide, one should be an O minus ion. Okay. The second reaction asks, one of the above pathways will result in the formation of another compound in addition to X. Identify the reactants involved in this pathway and write the structure of Y. So let's see what is going to happen. Okay. So this is a nucleophile, and this nucleophile will attack this alkyl halide to form this ether, right? But if you remember your organic chemistry, you need to know that a nucleophile also can act as a base for elimination reaction. base, which means what is the meaning of base? Base means it can take hydrogen and show elimination reaction. For an example, if you think about elimination reaction like minus HBr in the presence of alcoholic KOH, if you have alcoholic KOH, if you can remember, this OH minus will take H from one, Br will be removed from the other. So it is a base action. So in the similar way, one of these two pathways, our nucleophile can act as a base, which shows an elimination reaction. So we need to find which nucleophile can show that. Okay, so this nucleophile, you can see this will attach this CH3Cl directly, and here if this nucleophile act as a base, it should attack this hydrogen. That is the general rule. A nucleophile will attack the carbon, a base will attack terminal hydrogen. So if this is our base, it should attack this hydrogen. For an example, if this is our nucleophile, and if we have this alkyl halide, this should attack this hydrogen and remove this. There will be a positive charge here, and there is nothing to lose to form the double bond to complete the positive charge. But think about this. Okay, so what I am telling here, let's say this is our nucleophile, and this is going to attack this one and form the ether. But a nucleophile also can be act as a base. So typically what it should form here is, if it act as a base, let's say you have a hydrogen here. If it is acting as a base, it should attack this hydrogen, and this bond should form here. And here this one will be OH minus CH3. There is hydrogen here. Plus there is CH2Cl positively charged. This reaction would not happen because this CH2Cl in a positively charged scenario is completely unstable. Okay? Okay? So this situation is completely unstable. This pathway. Now we will think about our second pathway, where in that case we use this as our alkyl halide. And this as our nucleophile. Now, according to our previous reaction, this will go here and attack this and form our ether. Okay, but don't forget, I also told a nucleophile can attack as a base. So what is going to happen here? This CH3O minus will attack one of these hydrogens, and this will break here to form the positive charge here, and to make this positive charge diminish, this Cl minus also will be released. So H plus and Cl minus will form HCl, and there will be a compound which forms a double bond like this. So this is our Y, plus here HCl is eliminated. But here there is no way to form a double bond because there is only one carbon, and this situation is completely unstable. But here you can see nucleophile attacks the electrophilic carbon, but a base action attacks a terminal hydrogen, which breaks the bond to form first here a positive charge like this, Here it will be forming a positively charged primary cation. But here the adjacent carbon has chlorine now, so it can eliminate to give this wonderful compound Y, which has a double bond. And this situation is stable. So this is what they are telling. From one of the pathways, another additional compound can be formed. So what is this pathway? It is the pathway where we use our CH3CO minus, CH3O minus, and this entire compound as our alkyl halide. Okay, so this is what they are expecting from you. Okay, so write the reactants of each pathway discussed. So one of the pathways, so the structure of Y is this. Okay, so what is the type of reaction that Y is formed? This is attacking of the base. What is this? This is called the elimination reaction because hydrogen and Cl minus is eliminated from the system. So this is elimination, right? Assume that the reactants identified in 2 above, okay, form X by a 2-step reaction. Show how X is formed by writing these 2 steps. Use curved arrows to indicate the movements of electrons. So this is typically what they are asking at the end, right? So the reactants identify in 2 about. So what is the reactants? What is the reactant? What is 2 about? One of the pathways is result the form of this one, another compound Y in addition to X. Okay. Identify the reactants involved in this pathway and write the structure of Y. So this is Y, right? So what are the reactants? Sorry, this one and this one, right? Because here base action is this and forming this. This is our base action. Okay, I will stop sharing again. Okay. Yeah, assume that the identified in 2 form X. Okay, this form X by 2-step reaction. They are asking about the mechanism. So the idea is that. So what is the mechanism? First step is formation of this carbocation. I will draw on the top. So we have CH3O Na plus. We have hydrogen, Cl, hydrogens. So this will attack one of the hydrogen, then this will break. So this is our first step where it will form CH2 a cation here, Cl, hydrogen and hydrogen. So to tackle this H plus, in the previous pathway, I told you there was only this CH2 with a chlorine. There is no adjacent carbon. But here you can see this double positive charge will break here and this Cl goes like this. So which will be this is our first step. And in the second step, it is the formation of Y. Okay. So typically this is our second step. Okay. So first step is attack, base attack to form the positive carbon cation. Then the second one, there is an elimination reaction that is automatically happening because it has to remove the positive charge. Somehow it has to remove the positive charge. So elimination is favored here. Okay, delta G is negative here. So that is why this bond is broken like this and form its Y. So these are the 2 reactants that they are asking. And in the last step, they are asking about the mechanism. So this is the first step and this is the second step. Okay. So this gives the clear information about this particular question. So did you understand the question and the explanation? Okay. So this is a nice question. The first one is a little bit okay, easy. Second as well. Third, the part C is little bit tricky, but still, if you know about the reaction of ether. So ether, normally we study only this reaction. So typically you should know, if you study this one really well. Normally in theory class, I explain these two reactions. So if you know these two reactions, this is very easy because you know the substitution as well as you know the elimination in the formation of an ether. So ether formation is not easy, you can understand, right? You have to go through one pathway if you want to get a good ether. If you just don't care about the ether and if you don't care about the elimination product that is formed here like Y, you can go with any pathway. But if you specifically want to form one of the ethers that you want, you have to go with the first pathway that already I discussed, because it only forms one ether, no elimination double bonded alkene. But in the second pathway, it will form the alkene as well. Okay. So when you are learning about your organic chemistry, you should have learned this reaction as well. Okay, so question number 7 is okay. Now we will go to